Hello friends, in this video lecture we are going to learn about phase angle, phase difference and its characteristics. Let's start with the definition of phase difference. The difference of the phase angle between the two alternating quantities is called as phase difference. Let us understand phase difference with some examples. To understand phase difference, we should first know what is phase angle. So, in example 1, an alternating sinusoidal quantity given which is I is equals to 50 sin omega t. In this example, let Q is equals to omega t. Thus, the included quantity in sine angle is called as the phase angle. So, here phase angle is Q is equals to omega t. Now moving further towards example 2, two alternating sinusoidal quantities are given which are A is equals to B sin C plus P and P is equals to S sin C. Here in example 2, the difference in two phase angles is the phase difference between two alternating quantities, that is C plus P minus C is equals to P is the phase difference. Now let's move further. Now let us understand about leading and lagging waveform. Based on the phase differences, there are two waves, one is leading waveform and other is lagging waveform. Waveform that starts early or before is called as leading waveform, whereas the waveform that starts later or after is called as lagging waveform. In this particular sketch, we can see that there are two sinusoidal alternating quantities which are I is equals to Im sin omega t plus phi and V is equals to Vm sin omega t. Thus, as between these quantities there exists a phase difference of phi, that is definitely one quantity will lead and other will be lagging. In this sketch, as we can see that the curve of current starts from certain finite distance, that is phi, early with respect to curve of voltage. Thus we can say that current leads the voltage or voltage lags behind the current by a phase difference of phi. Moving further, here again in this sketch we can see that there exists a phase difference but of a negative value, that is minus phi. Thus due to this negative value, the curve of current starts after some finite distance, that is phi, after voltage. So in this sketch we can say that current lags voltage or voltage leads the current by a phase difference of phi. Now let us solve a numerical based on phase difference. The given problem is a 50 Hz sinusoidal voltage has RMS value of 200 volt. At t is equal to 0, the instantaneous value of is positive and half of the maximum value. Write down the expression for voltage and sketch the waveform. Here now let us move towards the solution. First of all, we will see what we are given with. Here we have frequency is equals to 50 Hz, Vrms is equals to 200 volt. At t is equal to 0, we have V is equals to V by 2, that is V is equals to Vm by 2, and we have to find the expression for voltage and the voltage curve. Moving towards its solution, as we know frequency is given as 50 Hz and Vrms we have 200 volt, and also we have the formula as Vm is equals to peak voltage is root 2 times Vrms. Now substituting the value of Vrms as 200 volt, that is Vm is equals to root 2 into 200, we get Vm is equals to 282.84 volt. Also we have at t is equals to 0, the instantaneous value of voltage is positive. the instantaneous voltage the instantaneous value of voltage is positive. That means at that instant, that is at t is equal to 0, the curve is some above x-axis, that is in positive half cycle. That is it means the waveform has started before t is equals to 0. That is due to the phase difference acquired, the at t is equals to 0, the wave has some certain value. So at a certain x is equals to phi, the value of voltage will be 0. So from so let us say it has started 5 degree earlier, that and Therefore, as we know, the equation is given as V is equals to Vm sine omega t plus phi. This is the standard equation of voltage, the sinusoidal alternating voltage. That is V is equals to Vm sine omega t plus phi. We will use the condition given that at t is equals to 0 we have V is equals to Vm by 2. So substituting the values, Vm by 2 is equals to Vm sine omega t plus phi. Here let us assume t is equals to 0 according to the given condition. So we have 1 by 2 is equals to sine phi. Therefore phi is equals to sine inverse of 1 by 2. Therefore we get sine phi is equals to 30 degree, that is pi by 6 radian. Therefore the expression for voltage becomes V is equals to Vm sine omega t plus phi, and substituting the value of phi as pi by 6, V is equals to Vm sine omega t plus pi by 6. Now substituting the other values, Vm as 282.84 sine omega, as we know the formula of omega is equals to 2 pi f, and we have f is equals to 50 hertz. So therefore substituting all the values, the final answer we get is V is equals to 282.84 sine 100 pi t plus pi by 6. Now moving towards this waveform sketch, so we have the equation V is equals to 282.84 sine omega t, that is 100 pi t plus pi by 6. So from this equation we get to know that the value of phi is pi by 6, that is a certain finite amount of distance as pi by 6. The wave will start from here, from this point, and also we know that the maximum amplitude of this sinusoidal quantity will be 282.84. now from this equation we get to know that the curve will be sinusoidal. So plotting the graph against x-axis as omega t and y-axis as v, we get a sinusoidal curve starting from a certain distance pi by 6 from origin. We get the following curve. So this is the sketch. So this is all about the phase difference and its characteristics. Hope all of you have understood it. Thank you.